If you find this video helpful, I would really appreciate if you subscribe, hit the like button, and leave me a comment down below in which things do you believe I can improve for the next video. Thank you very much. Hey guys, in this video I'm gonna quickly explain the dot product of two vectors. It is also known as the scalar product. Let's say we have a vector A and a vector B, and there's an angle between them. Let's call it theta. Dot product of A and B is written this way. Well, we write a dot A dot B, and it equals the magnitude of A times the magnitude of B times the cosine of the angle between them. As you can see, the dot product of two vectors is just a scalar itself. When would this be useful? Okay, it could be useful when calculating the work that a force makes on an object. There's another form we can write this dot product as, and it is this one. A dot B equals the component x of the first vector times the component x of the second vector plus the component y of the first vector, the component y of the second vector, and last the component x, the component c of both vectors. Okay, the multiplication of this and then the addition of them. Let's say we have these two vectors, okay, A and B. Note that they're in 3 dimensions. Now, what if we want to find the angle theta between them? The first part of the equation, the magnitude of A times the magnitude of B times the cosine of the angle between them. So how can we get the magnitude of both vectors? Well, if we remember correctly, the magnitude of A is just the square root of each of its components squared. So that will be 10 squared plus 7 squared plus 27 squared. Okay, and the square root of those 3 components. And it is equal to 29.6. Now we have to make the same calculation for the magnitude of the vector B. And B equals the square root of the components. The first component is minus 7. So minus 7 squared plus 9 squared plus minus 16 squared. Note that the minus is not important here because the square is gonna cancel it out, but I'm writing it anyway so as to make it a little bit more clear. And the calculation of this gives us 19.6. That's the magnitude of the B vector. If we look back at the equation, we see that A times B times cosine of the angle equals to the product of each of its entry multiplied by the entry of the other vector, the same entry. Let's calculate this. Okay, I just rewrote it. And calculating this, we have 10 times minus 7 plus 7, so plus 7 times 9 plus 27 times minus 16. We put this into the calculator and we have the answer that this equals minus 439. This is the value of the dot product of the vector A and B. Now we can see from equation, let's call this equation 1 and equation 2, that the both right hand side, they should be equal between them, okay, because they're equal to the dot product. So I'm gonna rewrite this part, writing down the right hand sides of both equations. We have A, the magnitude of A times the magnitude of B times the cosine of the angle equals the product of the components, bx plus ay plus ac times bc. Okay, so we can see these two that are multiplying, we can send them to divide, and we will have cosine of theta equals this factor that I'm gonna rewrite it as A dot B divided by the multiplication of their magnitudes, and then we can use the inverse function of cosine that will give us that theta will be equals to the inverse of sine, that of the dot product of A, B, divided by the multiplication of their magnitudes. These are all things we already know. So this is equal to cosine, the inverse cosine, of minus 439 divided by the multiplication of these two, that it is 29.6 times 19.6. We substitute this in the calculator, and this will give us that theta equals 139.2 degrees. That's a simple example that we can use the dot product to calculate something of two vectors. Now, take into account that this angle is in 3 dimensions. So calculating it just from the vectors without using the dot product will actually be very hard. But dot product luckily simplified it a lot. Hope you guys liked the video and it was useful to you. If so, I would ask you to please hit the like button, maybe consider subscribing, and if there's something you think I can improve, please leave a comment down below and tell me. I would really appreciate it. Thank you very much. Bye.